The best sand for the job is found 6 nautical miles out at sea. This sand is much more suitable. It's coarse, packs densely, and is more resistant to wave impact. They will dredge sand from the Gulf seabed. And there is an added benefit. The dredgers will spend less time transporting the material to the construction site. In just 3 hours, a dredger travels to and from the site, scoops up the sand, and sprays it into position. It works a 5 square kilometre area, dredging up the top metre of the sea floor. It takes less than an hour to fill the 8,000-ton tank with sand. The sand is then pumped through a pipe and sprayed into place at 10 metres per second, enough to fill an Olympic swimming pool in 4 minutes. The process is called rainbowing. The island construction team work round the clock to keep to the tight schedule. Night and day, the island grows bit by bit. The rainbowed sand builds into a sandbar, rising up to 4 meters out of the water. But for the engineers, there are mixed feelings. Is the shape of the island progressing as planned?
There was great excitement, and there was great anticipation, and a little bit of fear. Is it in the right place?
With doubt cast over the construction, Dubai has a trick up its sleeve. 676 kilometers up in space. Dubai has access to the only privately owned satellite in the world. It's so powerful, it rivals those of the Russian and US military. The satellite, IKONOS, orbits the Earth, taking pictures that prove the island is totally on track, so far. It also means the Crown Prince can keep a close eye on his pet project. August 2002, a year in, and the island team is ahead of schedule. 8 kilometers of the breakwater stands firm. 8 palm fronds break through the azure seas. But it's a grueling and difficult process. Rainbowing is a common operation in land reclamation. But this is no ordinary reclamation project. There is no mould for the palm shape and no fixed points to get bearings from. The unique shape makes it a nightmare to build because the whole design relies on accuracy. This enormous structure has 56 kilometers of waterfront and almost all of it is curved. To make things more difficult, it's impossible to tell from the ground if the sand is falling in the right place. The only way to complete this task is to use state-of-the-art technology.
Prior to GPS, we couldn't have done this job. There are only 2 straight lines in this project. All the rest of them are curved.
It's all down to a team of 5 men who walk the perimeter of the island every day as it takes shape. It's grueling work. Summer temperatures reach a searing 48 degrees Celsius. Humidity, it's 95%. With heavy packs strapped to their backs, these mobile receivers create a grid reference for the island. Receiving signals from space and a fixed position on land, the height and position of the sandbars is recorded. With these coordinates, dredgers can sail into the exact position and rainbow the sand with pinpoint accuracy. Only by using state-of-the-art GPS technology can this awesome megastructure take shape. As the world watches, the Palm Island becomes a reality. At the same time, faith in this tiny emirate is restored. Post 9/11, Dubai emerges as a safe haven in the Middle East. The beaches fill up again. Business resumes. The Crown Prince's gamble to continue construction has paid off. But there is still a deadline to meet. The island must be built by 2006. Coordination between the 2 teams, one building the breakwater and the other reclaiming the sand island, is crucial. If they don't work in perfect synchronicity, the whole project could be thrown into jeopardy.
If the breakwater progressed too quickly, it would cut off access for the reclamation contractor. If the reclamation went too quickly, then it would be at risk for the storms. We couldn't let one get ahead of the other in any way.
It's a delicate balance. But a year into the project, and incredibly, work is on schedule. Against all odds, the Palm Island rises above the waves, protected by the ever-increasing sea wall. It's a symbol of engineering achievement. But the engineers' biggest challenge is still to come: how to make the island safe to build on. The majestic Palm Island is only made from sand. But sand is unstable and highly susceptible to the movement of water around it. It also takes time to settle before it's strong enough to build on. But this awesome structure will support a city of 120,000 people, and their safety relies on firm foundations. This massive sand island must be made rock solid. But how? October 2002. Dubai is building the world's most audacious engineering project in the Arabian Gulf. A 5.5-kilometer island in the shape of a palm tree, made entirely out of natural materials. A year into the build, and 2/3 of the breakwater is complete. 8 kilometers of massive rocks piled 3 meters above the waves, backed by 200 meters of beach that will eventually carry 22 hotels. Behind this sea defense, the first 9 palm fronds made of sand rise above the water. Dredgers spray sand from the seafloor, a process called rainbowing, to create the first half of the 5.5-kilometer island. But building a man-made structure in the middle of the sea with only rock and sand throws up challenges every step of the way. The team constantly battle with nature as the sea erodes the work they do.
We worried initially that we could actually do it, that we could place the sand where it should be, that we could place the rocks where they should be.
The teams now race to finish the project. But then the engineers discover a problem that could put the whole project in jeopardy. The decision to start construction before completing the research has finally caught up with them.
Coming in or going out.
The sea is not circulating around this massive megastructure as they planned. The tides are not flushing the system properly. Clean water is not moving fast enough round the inner waterway. The water is in serious danger of becoming stagnant. People have paid millions for a piece of this paradise island. Green fetid water is not going to work. A solution must be found, and fast. Changes must be made to the design. But all the time, the Palm Island is taking shape to the original plan. Further tests are run on the computer. Luckily, the solution is found just in time, and it's simple. The seawall must have 2 breaks in it. 2 4-lane bridges link the sections of the breakwater. These 2 openings mean enough fresh-flowing water can get into the system. Twice a day, the tide enters the structure, pushing clean water around the fronds. Over 2 weeks, the entire waterway is replenished. But there is always a fear it may return. Environmentalists now test the water every day to check that the system is working. The return of algae and stagnant water is something they can't allow. With the water quality assured, the project is back on track. Teams race to finish the structure. 7 dredgers rainbow the sand, creating the last few palm fronds. Floating cranes lift the final rocks into place. By August 2003, the breakwater is complete. An awesome 5.5 million cubic meters of rock now holds back the full force of the sea. 2 months later, in October,